The addition rules of probability is where we are looking at probabilities dealing with at least two events occurring, but in order to use addition we are looking at either your first event or your second event occurring. Now we have two ways that we have to look at what I like to call OR events, and that is you either have duplicates or you don't. Now the reason why that is so important is because you can't count duplicates more than once. Okay, meaning if I had a classroom made up of both males and females and I was trying to look at events occurring and I wanted to know what the probability is of having both females and students with brunette hair in my class, well, there's going to be some overlap there because there's a possibility that I may have some female students that do have brunette hair. And so when that occurs, we have to subtract away those duplicate numbers. So you only want to be counted once when we're talking about probability. So we have two different ways that that formula is going to look. Either this first way says the probability that A or B occurs is such that the probability that A occurs plus the probability that B occurs minus the duplicates, so the probability that A and B occur. However, there are instances like the second formula here where you don't have duplicates. There is nothing in common. And so in that case, we would just simply have that the probability that A or B happens is the probability that A happens plus the probability that B happens. Since there's no duplicates, there's nothing for me to subtract away. So when you are looking at these, you have to determine if they are what's called mutually exclusive. Okay, mutually exclusive meaning nothing is in common or there's no duplicates. So I got a couple examples here. So first of all, we have this spinner, and notice my spinner's been labeled 1 through 8. And I've got two questions here that we have to solve. So the first one says to find the probability that you're going to spin an even number or a number less than 7. So the first thing we have to look at is we have to look at the fact that we have event A, which is the probability of getting an even number. So if we look at our spinner, an even number, we would have 2, 4, 6, and 8. Those are my even numbers. Okay? So when we're looking at the probability, my outcomes would be 2, 4, 6, and 8. So when we look at that, that's 4 choices over 8 possible choices. So I would have 4 over 8 as my probability. Now I would leave it like this because we have to remember your basic rules for adding fractions, which state you need a common denominator. So in this case, because I'm going to be combining fractions together, I don't want to simplify just yet. Now the second case I have to look at is the probability that I'm going to have a number so that x is less than 7. So for that to occur, I'm now looking at a second probability. So here is my 7. I want numbers less than that. So I am looking at 6, 5, 4, 3, 2, and 1. Again, I still have 8 total options, but here I only have 6 values to choose from. So my probability there would go 1, 2, 3, 4, 5, 6, which is going to give me 6 over 8. Okay. Now that being said, if you look at my two selections here, or even in looking at my spinner, you can see that some of my choices occurred more than once. So here, the probability that both occurred happened at 2, 4, and 6. So here we're looking at 2, 4, and 6 occurred both. So this is going to give me 3 out of my total 8. So once you find all of your individual pieces, what you can see here is that this is not mutually exclusive. So we have to state it. So the probability of finding an even or that my number is less than 7 is going to be the probability of my even, so 4 over 8, plus the probability that I'm less than 7, so 6 over 8, minus the probability that both occur, 3 over 8. Because my denominators are the same, I don't need to do anything extra. So 4 plus 6 is 10 minus 3 gives you 7 out of 8. Okay. Now in this case, we would also then write down its decimal answer. So you simply would do 7 divided by 8, and you're going to get that that probability is 0.875. Okay. So that is the first one. So let's look at the second one here. So again, we want the probability of even, and so we already know that. So we know that my probability of even is going to be 4 out of 8 because we used it in the previous problem here. But now we want to know, or the probability of 3. So the probability of 3 is going to be that I land on 3 and only 3. So this is going to be 1 out of 8. Now if you're looking at my evens, 2, 4, 6, 8, and my probability of 3, these do not share anything in common. Therefore they are mutually exclusive. So in this case, the probability that I have an even or 3 is going to be 4 out of 8 plus 1 out of 8. In this case, we're going to end up with my probability being 5 out of 8, which we all know probabilities are going to give you a decimal. So this is going to be 0.625. Okay, so in a nutshell, that is what we're looking at when we are looking at our probabilities. Alright, now sometimes we are given the probability in terms, or I shouldn't say sometimes, most of the times you are given a probability in terms of a word problem, and you have to be able to figure out what it is that you're doing based on the information provided. So in this first one, we have that a single letter from the word Mississippi is chosen. What is the probability of choosing an S or an I? So automatically there's a few things that we have to pay attention to. First, we have a keyword. The keyword right there is or. So that is automatically going to tell you that you're using the addition rules for probability. Now that being said, we have to decide if it is mutually exclusive or not. So we're looking at choosing an S or an I. Well, S and I have nothing in common with each other. So these would be mutually exclusive, meaning at no point are they ever going to overlap. So the first thing we have to do is we have to find the probability of choosing an S. So we're going to look at the word Mississippi, and essentially we're going to count up the S's. 1, 2, 3, 4. So here this is going to be 4. Now we need to know what our total is. So you have to count up all the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my probability of finding an S is 4 out of 11. Now I have to do the same thing for my probability of finding an I. Again, I need to count the I's. 1, 2, 3, 4. So in this case, I'm still going to be 4 out of 11. So my addition principle says I'm looking for the probability that I'm going to have an S or an I. And this is going to be the probability of S, so 4 out of 11, plus the probability of I. 4 out of 11. In this case, add them up, and this is going to give me 8 out of 11 as my probability, which has the decimal of 0.72727 and 3. Now the reason we have that 3 is because we are going to round. So if we take a look, You would use your scientific calculator, similar to this one. We would do 8 divided by 11 and hit enter. Now notice I've got a whole ton of decimals here, and we want to round to the millionth place, which is 6. So you would count 1, 2, 3, 4, 5, 6. Go to the 7th place, look at its number. This number is a 7, so we would round that 2 up to a 3. Okay? Alright, let's look at this next one. So here we have a bag of 11 marbles. So right away that tells you what your total is. So my total here is going to be 11 marbles. And it says it contains 5 marbles with red on them. So right away we know that we are dealing with red marbles has 5. 3 with green on them. So green is 3. 7 with black on them. So black has 7, and 4 with black and red. So black and red has 4. What is the probability that a randomly chosen marble has either black or red on it? So again, this piece right here on the end tells us what we're doing, and the or is the most important piece. Okay. Now in this case, if you look at our list of marbles, the first thing that might jump out at you is that these numbers don't add to 11. And that's fine, because if you look at a marble can have one color or it can have 5, 6 infinite colors. And so what we're saying here is that I have a marble that 5 of them have red on them. That's not saying anything about any other colors that appear on the marble, just that they have red on them. Okay? So the fact that these marbles don't add up to 11 doesn't matter. The total number of marbles here is what's going to be important. Okay? Now the other piece that's going to be important is we're looking for black or red. So first we have to look at the probability of getting a black. And that is going to be the number with black on them over the total. So here, the number that has black on them is going to be 7. So this is 7 over 11. Now I have to look at the probability of getting a red. So this is again going to be the number of red over the total. Well, I have 5 of them with red on it and 11 total in my bag. Last, I have some marbles that have both colors on them, so I also need to include the probability of both occurring. What this means is that these are not mutually exclusive, so we have to remove the marbles that would be counted twice. So this is going to be the number that have black and red, then over the total. And in this case, this would be 4 over 11. So here, if we want to find the probability of getting a black or a red, we would have to do the probability of black, so 7 over 11, plus the probability of red, 5 over 11, minus the probability of both, 4 over 11. In this case, again, we're going to come up with 8 over 11, which we already know from our problem above is 0.727273. Alright, let's try another one. So here we have that a reporter for an international newspaper is given an assignment that is randomly chosen from the following destinations worldwide. So we have 13 continental U.S. assignments, 7 South American assignments, 21 European Union assignments, and 5 Asian assignments. The question says, find the probability that he gets an assignment in Asia or South America. So this last piece, again, is your most important part. So we care about the probability of an Asia assignment, which we were told is 5. So this is going to be 5 out of, and we have to calculate our total, which we haven't done yet. And then we need the probability of getting a South America. So in this case, we would look and we have South America shows up right here, South America, and those had 7. Now with this, we have to find our total. So in order to find our total, again, we have to add everything up. So we go back, we had 13 continental, plus the 7 South America, plus the 21 European Union, plus the 5 Asian. And when we add all of those up, we get 46. So our probabilities here are over 46. Now, South America and Asia have nothing in common, so these are not mutually exclusive, which means in this case, the probability that we end up in Asia or South America is going to be 5 over 46 plus 7 over 46. In this case, that is going to give you 12 over 46, which, using your calculator, would give you a probability of 0.260870. Alright, this next one says, what is the probability that a card selected from a deck will be either an ace or a spade? So the first thing we have to remember is that my total is a deck of cards, and there are 52 cards in a deck. So looking at it, the probability of getting an ace means there are 4 aces per deck of 52 cards. The probability of getting a spade, well, there's 13 spades out of a deck of 52 cards. Now, with my spades, I will have an ace. So the probability of getting both is going to be 1 out of my 52 cards, because I have an ace of spades as one of my cards to choose from. So in this case, we would have the probability of getting the ace or spade is going to come out to being the probability of my ace plus the probability of my spade minus the probability of both. In this case, we end up with 16 out of 52, which is going to give us 0.307692 as a probability. Another way that you can see these probabilities has to do with reading results off of a poll table and use that information in order to answer some questions. So here I have a table that's talking about votes in an election, and we have males and females being looked at, and we are asking if you will vote yes, no, or undecided. So the first question says, what is the probability that a randomly selected student from this poll will be a male who has not decided whether he will vote in the upcoming election? So what we're looking at is we are looking at the probability of having a male that has not decided. So what we would do is we would come into our table and we would look at the male column, which we have right here, and we would look at the not decided, and the place where they come together is here at 21. So my probability is 21. Well, the other thing we have to do is find our total. So my total is we have to add all of this up. So we are going to sum all the terms together, which gives you your total of being 113. So my probability here is that 21 males have not decided out of the 113 students. Therefore, we would have a probability of 0.185841. Now the second part says, what is the probability that a randomly selected student from the poll is female or will not vote? So this right here is the important piece. And notice again, we have that or showing up. So in this case, we have to look at first the probability of being female. And again, we would come back into our table, and if you look, I would come to my female column and I would have to add all of them up to find out the probability of being female. And so this here would give you a total of 57. Of course, we still have that 113 to choose from. And then we need the will not vote. So then we have the probability of will not vote. So we would have to come over here and we would be looking at this no. So we would have the males and females that are no, so 19 and 11. So this is going to give me 30 over my 113. But then I do have some females that won't vote, so I need to look at the probability of both happening. So I would come to my female column and I would come down to where it says no, and that number would be 11. So here this is 11 out of 113. So just like before, we would put together our probabilities. So the probability of being female or not voting is going to be my female, so 57 out of 113, plus those not voting, 30 out of 113, minus those that are the same, so 11 out of 113. So this is going to give me a total of 76 out of 113 for my probability, which is 0.672566 as our probability count. Alright, let's try another one. Here we have two standard 6-sided dice are rolled, and we want the probability that the sum of the rolls is 8 or 12. So again, we have our important piece right here is 8 or 12. So the easiest way I would solve this is I would do what's called create a little table. So I know that I have a dice, so I've got 1, 2, 3, 4, 5, and 6. And then I also know that it would come down 1, 2, 3, 4, 5, 6. So what I've actually got here is I have across my the top here would be, say, dice A, and then I would have dice B. Okay, so this is what I have. And so we're talking about rolling. And so what we're going to do is we're going to fill in our table. We're going to go down in columns. And so essentially what I'm doing is here I'm going to start at the 1, and I'm just going to count up numerically. So this would be 1, 2, 3, 4, 5, 6, and 7. Over here I'd start at 2 and go 3, 4, 5, 6, 7, 8. Start at 3, count up 4, 5, 6, 7, 8, 9. Start at 4, count up 5, 6, 7, 8, 9, 10. Start at 5, 6, 7, 8, 9, 10, 11. And then 6, 7, 8, 9, 10, 11, and 12. Okay, so I have filled in my table here. Now the reason why this is important is because it's going to allow me to pick things out very quickly. First and foremost, I want to know rolling in 8. So here I can look, and these are all of my 8s right here, so I can go ahead and circle them. And so if I want to know the probability that I'm going to roll an 8 or sum to an 8, I've got 1, 2, 3, 4, 5 options, and because I have 2 dice, I would have 6 times 6. So here this is 6 times 6. That's how you represent your 2 dice. So this would be the same as 5 over 36. Now I also need the probability that I'm going to get my 12. And so in this case, if I wanted to look at 12, I would look in my chart for a 12, and I only have one spot where that is possible. And so here this would be the same 1 over 6 times 6, which is going to be 1 over my 36. And so in this instance, what we would have is that the probability that you're going to sum to 8 or 12 is going to be 5 plus 1 over my 36. 5 plus 1 gives me 6 over 36. And in this instance, we could go ahead and reduce. So this is going to end up being 1 over 6 if you so choose, and its actual probability is 0.1666667, again because we would round up. Okay. Now I find that creating this or doing this table makes it very easy to be able to pick out what it is I wanted to sum to. So I highly suggest working with that. However, there are other ways that you could approach this problem. If you do find that creating this table is confusing, please let me know, and I'd be more than willing to help you work through some of the other approaches to solving a problem like this one. Alright, the last one I wanted to look at is here. I have a jar filled with tiles numbered 1 through 30. If one tile is randomly drawn from the jar, I want to find the probability of the tile having a number divisible by 4 or a number between 17 and 27. So the first thing that I would do if I were you is I would go ahead and list out my tiles if you want. So here you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Alright, now the reason why I would do that is because I know firsthand that sometimes working probability problems can be a little overwhelming, and so it's easier to just go ahead and draw things out. So the first thing that we want to look at, and I'm going to go ahead and use colors for this, is we want to find the probability that we are divisible by 4. So we already know that there's 30 tiles and that is our total. So we want divisible by 4. So one thing that I would go in and do is I would go ahead and just start looking. I know that 4 is divisible by 4. I know 8 and 12, 16, 20, 24, and 28. And so I would just go ahead and identify them, and then I can easily count them up. 1, 2, 3, 4, 5, 6, 7. So this would give me 7 out of my 30 tiles. Now the other piece that I want is I want the probability that we are going to be between, so 17 to 27. So here we are looking at 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. So here again we can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so once we've done that, then we can go ahead and look. If you look, the reason why writing these tiles out is a very easy trick that you can use is because here you can clearly see that I have some tiles, 2 of them for sure, that fall within the category that we wanted, which is divisible. And so here we've got the probability that both occurs is 1 and 2. So here we have 2 out of 30. So in this instance, the probability that we would have divisible by 4 or between 17 to 27 is going to be the probability we're divisible by 4, so 7 out of 30, plus the probability we fall between 17 and 27, so we have 11 out of 30, and then we have minus the probability that both occurred, so 2 out of 30. And so in this case, we would end up with our probability being 16 out of 30. And if we go ahead and find your probability, this here would be 0.533333. Technically, your 3 is repeating, but we don't necessarily get that far into it. Okay. So there you have it, a good introduction on quite a few different approaches and different problems dealing with the ideas of with addition using your probability, so addition rules for probability. So if you have any questions, please feel free to let me know. Otherwise, I do hope this video helped, and I'll see you next time.